So hello everyone. As we know that we were studying about the organic chemistry. So in today's lecture, we will continue with the organic chemistry and also we will try to cover some more aspect regarding the organic chemistry. Okay, so let's start. So here is the functional group which we need to study in this lecture. Okay, but before starting these things, let me clear you several facts. First is the catalyst. Second one is our ethanoic acid. So about these two things I had mentioned in the previous lecture. Okay, so you just try to remember these things. Okay, first is our ethanoic acid. Ethanoic acid. Okay, so what do you mean by ethanoic acid? And how does ethanoic acid related with the carbonic compounds or the organic chemistry? Just remember it, recall it, and then you will recall. Then it is a part of saturated hydrocarbon. Remember, part of saturated hydrocarbon. Okay, and do you also remember what do you mean by oxidation and reduction? These two topics we had discussed also in our previous lecture. If you're not, then let me recall it so that you can get a revision of it. Basically you can say oxidation is basically a type of chemical reaction in which product getting oxidized. It is a type of chemical reaction where product getting oxidized. For example, if it's A reacts with B and produces AB. So these are the reactants. It is the product. Remember? Okay. So suppose in this condition, when they both reacted and the AB getting oxygen or getting oxidized. So it is a oxidation reaction in a simple terms. Got it? Similarly we can say for the reduction. When a product loses oxygen. Okay, so reduction is a process when a product loses oxygen. Okay, like A plus B. Similarly, they are the reactants. Similarly, they are the reactants and they produces A and B. A and B. A and B. And A and B is basically the product. Remember? So in this scenario, suppose here they having the oxygen on the reactant part, but here in the product part they loses the oxygen. They loses the oxygen. So it is a part of reduction reaction. It is a part of reduction reaction. Got it? Here they gaining the oxygen, here they losing the oxygen. So it is a part of reduction reaction. Got it? So basically the ethanoic acid related with the oxidation part of saturated hydrocarbon. Okay, in this scenario I had told you that the ethanol uses as a base and thereafter potassium dichromate used along with sulfuric acid. Okay, so you can say the ethanol reacts with potassium dichromate and sulfuric acid to produce ethanoic acid. Okay, here ethanol is a base, potassium dichromate basically used to oxidize the reaction, and sulfuric acid basically used to acidify the reaction. Got it? So that's how our ethanoic acid produces. Now we have to learn about certain properties of the ethanoic acid. Got it? So let's start. Okay, so number one is ethanoic acid, also known as acetic acid, and it is also known as vinegar. Got it? So the ethanoic acid also known as acetic acid, and acetic acid also known as vinegar. Got it? Number two, that the melting point. I had told you melting point in the previous lecture of ethanoic acid is 290 K. K here stands for the Kelvin, and we had discussed that Kelvin, Fahrenheit and Celsius are the degree used to measure the temperature. Got it? So the melting point of ethanoic acid is 290 K. So it's often freezes at cold temperatures. Got it? So that's why it is also known as glacial acid. It is known as a glacial acid because it freezes at colder temperatures oftenly. Got it? Third point is about its physical properties. So here I am going to tell you about two things. First is a physical properties. Second one is a chemical properties. Properties. What do you mean by this? Physical properties basically means appearance, shape, and size. Chemical properties basically means composition, reactivity. Okay, so if we are talking about the appearance, shape and size of an object, then we are talking about the physical property. If we are talking about the composition of an object and the reactivity of an object, then we are talking about the chemical properties. Got the difference? Note it down. So about the physical properties of ethanoic acid, then it is colorless, pungent smell, thereafter second one is it is miscible with water, in all portions, and second is turn litmus paper to red. Got it? So it is colorless, having a pungent smell, so you can easily smell it. Okay, like the vinegar. If you have used vinegar in your house, then you must know that the vinegar smells pungent. Okay, and it has a acerbic smell basically. Second one is as it is miscible with water in all proportions, so it could be dissolved with water easily. Third point is turn blue litmus paper into red because it is acid, and in our lecture of acid, bases and salts, I had told you that acid turns blue litmus into red, whereas base turns red litmus into blue. Got it? Now about the chemical properties. So basically it is used for two things. It is basically used for two things. First is a esterification. And second one is a saponification. So basically ethanoic acid chemically used for these two processes. And what are these processes? Let's understand. So basically the esterification is a reaction. Esterification is a reaction to produce esters. Okay, and esters are basically used for flavoring agents or sweet smells. Okay, the perfume which you use is basically made of esters. Got it? And also the most of the drinks and things which you consume basically, and they are sweet smelly, so these are the esters. Okay, if anything which smells sweetly, then these things are made of their esters. Got it? And you can say basically the simple definition of esters. If I ask you what do you mean by esters in a simple terms, then you can say ester is a compound that react to produce alcohols, organic and inorganic, or you can say or inorganic acids. Okay, so that react with water, basically with water to produce alcohols, organic or inorganic acids. And these basically the esters are used for flavoring agents or the sweet smelling agents in various processes. Got it? So it is regarding the esters. Okay, so now let's back to our esterification reaction. So in the esterification reaction, basically ethanoic acid reacts with alcohol in presence of concentrated H2SO4, or H2SO4 basically used for sulfuric acid. Basically used for sulfuric acid in the presence of concentrated H2SO4. And H2SO4 act as a catalyst. I will tell you about the catalyst little bit. Okay, so basically is during the esterification reaction, ethanoic acid reacts with the alcohol in presence of concentrated H2SO4 to produce esters. Got it? So it is regarding the first thing, okay, which we have discussed here. Now come to the next reaction. Which is a reaction of saponification. Got it? So basically in this situation, esters reacts with sodium hydroxide to produce Weed smelly soaps. And detergents. Got it? So basically, if you remember that during the acid and bases chapter, I had told you that base basically used for soap manufacturing. Got it? So saponification is a process of preparing soap from the ester. In this situation, esters react with the sodium hydroxide, which is a base. Okay, and then it provided sweet smelly soaps. Got it? So saponification is a reaction for soap manufacturing. Got it? So if we talk about the soap, then we should talk about two main points also, which is the soap and the detergent. Soap and the detergent. Soap versus detergents. Got it? So first about soap. So soap are the, just write these points which I'm telling you. Soaps about the sodium or potassium salt. First point. Second point, less efficiency in hard water. Third point was soaps are biodegradable. Got it? So basically you can say soap are the salts of sodium or potassium. Okay. Second point is that they are less efficient in hard water, and third point is that soaps are basically biodegradable, so they are non-harmful. They are non-harmful. Got it? And there are two types of water, hard water and soft water. Okay. In the context of soap, we just remember that in the hard water, the soaps are not generally efficient to make a bubbles. Okay. And but in the soft water, they are able to make bubbles. Got it? So due to this, soap efficiency in hard water is less because they are unable to make large number of bubbles. Got it? Now come to the detergent part. Number one, it is a ammonium and sulfonate salt. Number two, it is having high efficiency in hard water. Thereafter, number three, non-biodegradable. Got it? So basically you can say detergent are basically the salt of ammonium and sulfonate. Second, they having the high efficiency means they are able to make more bubbles even in the hard water. And the third point is that they are non-biodegradable, so they are harmful for nature. Okay, so here we have finished about the soap and the detergent also. Got it? Now let's come to the catalyst part. Catalyst part. So basically, catalysts are the substance. Catalysts are the substance used for increase rate of reaction without affecting or consuming itself. Okay, so basically catalysts are a substance which are generally used to increase the rate of reaction and they are unaffected by the reaction. For example, here A is a and B is a reactants, but C is a catalyst. Okay, and you want both A and B to get reacted, but their rate of reaction is slow. So you just need to put C inside their reaction. Then the product which you will get is A and B. But remember, here you have put three things, A, B and C, but you only getting AB because catalyst is generally used to increase the rate of reaction but not to get consumed or not to get affected by itself. So C will generally raise the rate of reaction but it will not get consumed by its own. Got it? So that's why instead of getting A, B, C, you are getting only A and B because C is not affected by this reaction. Got it? So it is an example of the catalyst. Okay. Now let's come to the functional group. What do you mean by the functional group? Basically, the functional groups are specific groups of atoms within a molecule dedicates chemical behavior and properties. So suppose if this is the molecule which is made up of 4 atoms. Okay. So basically, what are the behavior of these atoms? What are the behavior of these atoms will define the behavior of this molecule. So you can say it is a specific group of atoms within a molecule dictate its chemical behavior and properties. So basically the atomic or chemical behavior of these atoms will define the property and the chemical behavior of the molecule. Got it? And so that's why these are the functional group. Just for an example, just take an example that A, B, C, D are highly reactive. So the molecule will be highly reactive. But A, B, C, D are moderately reactive. The molecule will be moderately reactive. But A, B, C, D are less reactive. Then the molecule will be less reactive. Got it? So these are the reactive centers where the chemical reaction take place. Okay. So from the examination point of view, what we need to learn in this chapter. So basically you just require to learn the different names of the functional group and some facts about them, which I have put in the slides for you. Let's start with the first one. So the first group is hydroxyl group represented by -OH. Got it? It is generally found in alcohols, phenols and imparts polarity, hydrogen bonding and alcohol-like properties. So just write down the first is a hydroxyl group represented by -OH. It is generally found in alcohol and phenols, imparts properties like polarity, hydrogen bonding and alcohol-like properties. Got it? Move forward. Second one is our carbonyl group, basically represented by this. Okay, and this imparts double bonding. Remember, single, double and triple. Remember, no? So here if you are seeing this, then just recall it is a double bonding. Got it? And if it's a double bonding, it will be unsaturated hydrocarbon. Got it? So basically, for second one is a carbonyl group represented by this. Now, what's about the properties? It is present in aldehydes, ketones, carboxylic acids, and esters. Okay. Aldehydes or ketones are involved in various addition and oxidation reaction. You got a one more point that the aldehydes plus ketones engage in various oxidation and various reduction or addition processes. So just write down this point also. Got it? Now let's move forward. It is a amino acid. It is a third group represented by minus NH2. Represented by minus NH2. Okay. So basically it is found in amines, compounds related to ammonia. Compounds related to ammonia. Got it? What are the properties imparts? Imparts basicity and participates in various chemical reaction. It is highly inclined towards base. So that's why it shows the property of basicity. Got it? And participates in various chemical reactions. So you can say it is a chemically active group. Chemically active group. Got it? Now let's move forward. Then the fourth one is a halogen group represented by these symbols. You can write down these symbols. Okay. Single halogen atoms, fluorine, chlorine, bromine or iodine bonded to a carbon. So you can say this will be like this because it is a single bond. And because it is a single bond, then it will have only saturated hydrocarbon. Got it? Affects reactivity and properties of the molecules. So you can say if halogen group is present within the molecule, it will affect the reactivity and the properties of the molecules as per the properties of its own, which is like the single bond. Got it? Now let's move forward. Fifth one is a sulfihydryl group represented by symbol this. It is present in thiols and can form disulfide bonds and participate in various reactions. So you can say it is also chemically active because it can participate in various chemical reactions. Got it? Just write it down. Let's move forward. Now we're having a topic of isomerism. So basically, what do you mean by isomerism? Isomerism refers to the phenomena where two or more compounds have the same molecular formula, like A and B having same molecular formula, means the molecule composition of this will be equal to molecule composition of this one. Okay, but different structural arrangements or special orientations. So you can say when the molecular composition of this and the molecular composition of this means A is equal to the B in terms of molecular composition, but they both are differ. You can say both differ in terms of molecular structure. In terms of molecular structure. Got it? So it is about the isomerism. When two compounds A and B or any other compound having the same molecular composition but their molecular structure is different. In this condition, it is known as the isomerism. Now move forward. We have two types of isomerism. First is structure. So compounds have the same molecular formula but different connectivity of atoms. Means molecular composition of A will be same to of B, but their atomic orientation will be different. So this case is a case of structural isomerism. Got it? Now, second one is a stereoisomerism. Compound have the same molecular formula and connectivity, but their atoms are arranged differently in space due to restricted rotation around certain bonds. So you can say molecule composition of A is equal to molecular composition of B, and also the atomic orientation same at certain points. But here is one thing, that there is a restricted rotation around certain bonds. So only certain bonds having some restricted rotation. So you can say the molecular orientation of A is getting differ to molecular orientation of B because of this restricted rotation around certain bonds. So this is a form of stereoisomerism. Okay, so in this lecture we had completed the organic chemistry. In the next lecture we will start with periodic table and certain trends. So we will learn the things in a depth. Got it? Till then, thank you.